Good afternoon, everybody. Welcome to second routing working group session. Please read not well. It's an updated version. You know, all your contributions to IETF and IETF process are public domain. Please be aware before you contributing to IETF. Before we start meeting, we would like to bring up one, maybe not issue, but we need to make a decision.
So yeah, there's one more document that that we didn't review on Monday in our first session, and this is a working group document that's kind of dormant. It hasn't been updated in at least 6 months or more, and this is draft IETF RTGWG policy model. So this is the routing policy model that was originally produced about 2 years ago, I would say. And it uses the open config paradigm with a state container with config false. So this model is not NMDA compatible. It's not compatible with the new data store architecture, and it's generally not the direction that the IETF agreed to go on. However, it's probably still a useful model, but I won't prejudge things here. But so it doesn't show up under the documents under the routing area working group, because stuff that gets archived doesn't automatically show up. It just kind of times out, but it's still there, and it's still a working group document per se. So we've got several options that we can follow here. I've listed them out here. So option number one is that we do nothing. I guess that would mean that we don't think we need a routing policy model, that we don't think this work is useful, to finally standardize. Second option would be to use this existing draft as a starting point and evolve it into an NMDA compatible model. The third option would be to create a new draft as a starting point for the NMDA compatible model. Acknowledge the existing authors so that we're not just trying to steal credit or anything. So there's a similar issue in BGP that occurred with one of the BGP models, and we can do whatever we want, but it's an issue that if we find this to be a useful model, then we should figure out how to move forward on it, either based on the existing document or just start over with a new document that follows the IETF gang modeling versions or approach.
I rise to speak against option one. IDR has to have this model, so if it doesn't turn into an NMDA, that's model, the IDR group will have to do something for policy instead of sharing it. So I speak for option one or two.
That was you heard,
AC Lind of Cisco Systems. Yeah, I think we need this to have a deployable solution both in all the routing protocols. And I hate to say I'll do too much, but I'd be willing to work on this type of model. I mean, this model. Somebody who's implemented route policy at least once, twice.
Okay, so that, and I wanted to correct. So Sue, you said one or two, but you meant two or three, I believe, right? That you don't like option one, right? That I just want to
speak against option one. Option two or three works because we have an MDA model.
Yes, yes. Thank you. I just wanted to clarify because I think there was a miss.
Stefan from Orange. I'm completely against option one. I cannot imagine to not have any routing policy. Does someone deploy routing protocols without any policy?
I put option one there as a somewhat rhetorical.
This is an option.
It certainly is an option, right? So just wanted to make sure that we do have motivation in the working group to move forward on two or three.
Now, option two or option three, I think it's more a question of politics. We can do whatever we want. There are plenty of good things in the current models that we can reuse, so we can just modify the current documents, make it NDMA and MDA, compatible, or create something new to kind of acknowledge the work that has been done by open config guys, whatever.
Perhaps to explain in detail, it's not only that it's not compatible with our advice how to build data store, it uses OpenConfig type depth and wouldn't compile. It's not an ATF model.
Yes, not
So,
open.
you can continue.
So the other point is the IDR BGP model is holding on this. So I do have, because I'm an IDR chair, I have solicited authors who were willing to help on this or have already written it. But I don't want to take, it would be in the using the number 2. So we hope to get the BGP model out that depends on this in 2 weeks. So we really would urge quickness. The operator said, please move fast. And we had a prototype one because we had to build our stuff.
So the plan is to contact the author of original draft, Anis specifically, perhaps, and ask whether they want to keep working and make version 2 an IETF document. If they say no or disagree in general, then probably we would move to option 3, fully acknowledging their input, their work, and starting new work in routing working group.
Okay, so there's that's a month or 2 away for your stuff, for the routing working group version. There's a month or 2 before you get to option 2 or 3. That's what I heard in that, right, Jeff?
They said that we are going to contact author today, probably.
Okay,
So
thank
it's
you.
not 2 months.
So Rob Wilton, Cisco, I mean, I quite like option 2 in terms of it being quicker to do. I converted the Yang model as part of that draft when I was doing the BGP model. So the actual conversion to NMDA is done. It's just, I mean, as a starting point, if you want to be quick, if you had any pushback on this, is do option 3 and just start by putting the Yang model in the draft. So at least that's there, and then build the text around it.
Yeah, so we don't want to go back to the discussion, use my stuff without my permission, you didn't acknowledge me. We fully acknowledge the work author did, and we would like to be good citizens and first approach them before we do 3. I know we can convert it easily, and we'll probably do it, but I would like, again, us to be good citizens and show goodwill.
Of course, agreed.
Yari?
Okay, thank you. My name is Yaryak. I want to talk about network virtualization and slicing. And the background for this work is manifold. Obviously, the growing importance of various virtualized solutions. There's a lot of work in the IETF on data models, and they talk about virtual networks in many cases as well. In 5G, we have this slice concept that we've talked about in various contexts at the IETF last time at the net slicing book, for instance. And I guess part of the motivation for doing some work on this is that we were a little bit frustrated about discussions around net slicing in particular. And it was a feeling that we were discussing something from a very top-down fashion, that we have this nice concept that isn't necessarily exactly precisely defined, and then keep on providing some level of detail there, but not all the way, and in particular, no linkage to what's existing. And obviously, you would think that if we have a concept for virtualization in the networks, that would probably use some of the existing technologies. So we want to try and understand that a little bit better. And we have a couple of observations to start with, and then we'll go through with a quick review of the things that are going in the IETF on this topic. and then we'll finish with some discussion of, okay, what now? Are there some architectural implications, and what kind of new work we should perhaps be doing? So, but start with some of these observations. The first observation is that the terminology is really important, but it shouldn't necessarily drive like the innovation of new technical means. So as noted, like 5G slicing should be able to rely on many existing technologies or technologies that are currently under development on VPN space, traffic engineering, data models, quality of service, and so on. And the other thing is that there's obviously a big role for software here. So it's a little bit of a question mark. Like, we are the protocol guys at the IETF. We always think about stuff in terms of protocols, but it's important to understand like what's the role of protocols and standards and software in this particular case. And the role of software is really big. So I mean, obviously many virtualization tasks can be achieved through software without actually touching the protocols. You have some piece of software that creates these connections between networks and the actual protocols that you run in the networks or between the networks don't actually have to change in many cases. That's not always true, but it's important to realize that that's true for a lot of the cases. I should also talk a little bit about like the different kinds of technical details here. So it's important to separate what do we have in protocols. Sometimes we have some capabilities like you can create this virtual private network on top of some existing data plane. Sometimes you have descriptions of virtualized networks as data models that are important, but they're not the ones that, I mean, it's not something that happens on the wire, but it's rather a construction in memory and then maybe modified through protocols, but it's a different type of an entity than the actual on the wire protocols where payload traffic goes through. And then we have concepts which may be important for the industry so that we can actually talk about stuff that I am doing this, or you and I agree on some kind of SLA, and it'd be useful to have some terminology that's common to us so that we wouldn't have to start from ground zero when we try and understand what each other is meaning. So with that, I want to go to sort of a quick review of IETF technologies in this space, and this is really quick. And I should also mention that I'm personally, although my co-authors are more experienced, but I don't know much about this. I'm a generalist. I'm trying to understand the space and ask some stupid questions and try and figure out where are we at the big picture level. So there's certainly many things that I'm missing here. Please come to the mic and comment at the end so we can build a better full picture. And so virtualization technology, it generally doesn't necessarily affect our payload traffic, TCP, IP, and applications. And that's true for almost all cases. There's some exceptions to this. One sort of obvious case is when you have some assumptions that are built into protocols that get broken due to virtualization and or sharing of resources and such, and then typically will be a need to add some information to some protocol somewhere to resolve the broken assumption in some fashion. And the example here is early HTTP versions basically assume that one server equals one website. That's obviously inconvenient for many reasons. So now we have virtual hosting, but as a result, in the application layer protocol, you have to actually carry sort of the intended website name inside the protocol. Then a little bit sort of outside IETF, but also partially inside, lower layers obviously can carry virtualization related information. As an example, VLAN tags and Ethernet frames. There are some cases where we also do sort of similar things in IETF protocols. If we have a tunneling protocol, it sometimes can indicate like we want to get to this network using some tags or some identifiers. We also have like AAA protocols or some authentication protocols like EAP that can indicate domains in some abstract sense, and those can be used to determine which network or virtual domain you want to connect to. Then we have endpoint VPN technologies, IPsec-based VPNs as an example. We have provider-based VPNs and associated technical components, the slots in the space. Probably should have added to the slide also data center virtualization technologies. NDO3 is one working group in this space. We also do a lot of traffic engineering work at the IETF PS working group as an example, enhancing the traffic engineering capabilities in MPLS and TMPLS networks. We have tunneling technology, again, plenty to list here, just a couple of examples. Service chaining, also sort of a component, this overall picture. We can build virtual services on top of real networks using service chaining. We also have management frameworks, obviously tools that we can use to manage our real and virtual networks. And then we have data models, and particularly for virtualized case, we have some working groups listed here, L2SN, L3SN. So that's the high-level review of what kinds of things we're working on here. Is this better? Okay. And then drawing on some architectural observations from this work and sort of what's going on at the IETF and the world in general. So obviously the increasing role of software is really important. So not all things are going to be specified by protocols, and not everything that the network does is specified by an action of the routing protocol or some other component of the network that we at the IETF have been used to doing. But a lot of these things that happen in the network are things that the software components or sort of intelligent controllers and such do in the network. There's also a trend of centralizing various kinds of functions, which is obviously making things easy. You put route computation or some virtual network building functionality or SDN control in a central place, and that's just makes a lot of engineering sense. I just wanted to point out a couple of things that one has to keep in mind there. So obviously one question is, what happens if you have some kind of network partition situation, your center is down, what do you do? Ways to deal with that situation are obviously useful. There's also sort of, currently we don't have an issue here, but I was kind of wondering about where this development goes in the end. I wouldn't like to see a situation where sort of centralized networks, a large ISP or a content provider, for instance, would somehow be in control of the network edges more than they are already today. So I still want to design my own home network the way that I want to. I don't want my ISP or content provider or a social media network to tell me how to do things, and sort of a nightmare scenario there that this ability to centralize things and control things and build these virtual networks might affect that someday, perhaps. But maybe that's just unnecessary fear. I don't know. I just wanted to bring it up anyway. The other thing that I sort of observed that the industry seems to be going back and forth a little bit, like over time. It's a pendulum between different extremes. And currently, we are talking a lot about like we, need to provide this specialized service or tailored service, with exactly this QoS and exactly this kind of bandwidth and these connections and this RTT between these parties. And that's all great. I have many customers who want exactly that, and I know that they really need it. But I think at times you probably need some balance here, because it's also true that you probably don't have this for everybody, and economically, I don't think we can have that for everybody, because usually we have like this, part of the economics of the internet is that you have the general purpose service. You don't have to tailor your routers for all applications or for all users. You just have, provide internet connectivity, and that's, it has a certain cost, the service, but at least you don't have to touch it for every possible application or user. And I think it might be time now to reflect a little bit on that. Even though we talk a lot about slices or virtualization and the specialized services, we shouldn't really necessarily assume that that's everything. I'm predicting that there's a fairly large component in networking that is still sort of bulk service, whether it's best effort or whatever, but it's still, one size is going to fit billions of users kind of situation. I think I don't have numbers actually, but in the mobile networking case, for instance, what's the fraction of smartphone users versus other IoT or other cases? I think probably 90% would be a good guess for smartphone users, and that feels like an area where we will also in the future be offering, a couple of different classes of service or speeds for end users, but not tailored for, certainly not individuals or even in more detailed fashion. So let's keep that in mind. The other thing to think about, I think I haven't really personally done at all any work in data models and so on at the IETF or elsewhere, but it does seem that there's some role here to think about the layering between different models. And there's obviously at least data or control models that you can use to control the behavior of your individual devices. You have, probably something at the level of networks. We're also seeing these service models that are more abstract models. That I want this kind of VPN service between these endpoints, and then you have to map between these different layers and thinking about that, how the different pieces in the IETF fit together is really important, particularly when we're thinking about new work. And the next point is about general designs and specific designs. So here I was thinking of the requirements from 3GPP and 5G on slicing. And, it's in some sense, it's a little vague at the moment because they don't have their final requirements set. Of course, the way that the specification work operates there, it's once they decide their final requirements, then 5 minutes after that, everything, all the standards and products need to be ready. So it's kind of late to wait for that. But at the same time, the IETF, like we have our own work products and our own technologies. It's our job to keep our virtual networking technologies, competitive and have the features that we think our users are likely going to need. And I would actually argue that it will make sense for the IETF to think about this from, take all the possible inputs, yes, from others like 5G work, but do our own analysis of what do we need to build for our own tools in terms of data models and other pieces of work, instead of narrowly building for a particular requirement. I think we can get some hints at least of what direction requirements are likely to be at. And this also should provide more longevity for our designs than a particular release in some other SDO as an example. So coming more towards the end, possible new work. What should we be working on in the IETF in this space? In a lot of this we are already working on, obviously, but just wanted to sort of paint the picture from my simplistic perspective. Obviously, we're going to be working on data models, and that seems like a useful thing to do for the virtualization service and all the other layers. And again, figuring out correctly what how these things fit to each other, what the overall picture is. We also, I think, it seems like a natural IETF role to manage heterogeneous networking So when you have different kinds of technologies underneath, or your management tools are different in different parts of the network, to be able to provide some overall building of these networks for those kinds of situations. I think that's a very natural fit for the IETF. Also, I should mention that there's probably some underlying VPN protocol or API or data model capabilities that we should be looking at. My colleague Balas was mentioning the other day that he would like to see, or he feels that there are some cases, particularly in radio. He was thinking about the radio aspects in particular, that you can, if you're trying to think about things that are, hard guarantees that we'll give you 1 gig, forever on this link, then that's a thing that we can try and provide over wireless. But there's probably some likelihood that a truck passes through the beam or something, and for a few seconds we can't actually provide that. So being able to provide guarantees that are softer or statistical might be a useful thing to have. Cross-domain, doing all of these things over multiple administrative domains is obviously very interesting, and it's part of the requirement set. I think we were doing some work around those things, maybe at the IETF, if I remember correctly. The point that I want to make here, though, is that that's really hard. So, proceed carefully. And then the final point, this isn't about the technical things, data models or protocols or any of that, but again, if we would actually agree about some technical things in the industry, that would be a useful thing for all of us to discuss with our customers or each other and so on, or even standards discussions. Currently, it's difficult because I say slicing and you say slicing, and we mean totally different things. So that's I'm not saying that that's necessarily an IETF thing, but it could be an IETF thing. You have a comment?
Yes, because Greg Mirsky, ZT. One of the NetSlice use cases is ultra reliable and low latency services. And I think that's where their performance measurement SLA assurance is a critical thing. So yes, we do have some performance measurement protocols here at IETF, and so I believe the radar. What might be interesting is how that works end to end when we have heterogeneous net slices radio to the packet. So where you think it belongs, because there's something, it might be not, I agree, there may be, we don't need the new protocols, but we need to see how it works. So basically how we can do SLA assurance and basically monitor that SLA being delivered and serviced proactively, because the services are so critical that we cannot operate network and wait for the client to say, oh, I lost my service.
You bring up a very good point. I actually didn't include measurements or monitoring in the slides, but that definitely should have been an item there, and that's needed and might require some new work also in terms of
thank you.
Special requirements that we're seeing. By the way, I have one more slide, so before everybody comes up, so I could maybe speak to that, and then we can just discuss. Unless you were on this.
No, go ahead.
Okay.
Go ahead.
So I just wanted to finish with next steps. So I kind of view this exercise, and this is like from our part, just a really tiny exercise. We haven't done much. We were a little late submitting the draft as well this morning. But I think it would be useful to connect the sort of a top-down approach that some people are taking into like slicing, and then the bottom-up approach, figure out where they meet, and then you have a bigger or fuller picture. And then we should determine what concrete things we need to do over existing technology. And maybe it's very little, Maybe it's more. I don't know. And then my dream is actually maybe between this IETF and the next IETF, we actually figure this out on lists and together. And then we know that, we need to do this data model and this enhancement in that other protocol. And then we push it to the existing working groups. And then that's the work that we need to do. So I think success is actually reasonably easy if you take that approach instead of like this big bang, totally new concept, very complicated approach. And the data model development, obviously with virtual networks, seems like it should be a continued topic for the IETF. And this isn't just for 5G. This is for other purposes as well. And it isn't only between like IETF and IETF's consumers and other organizations. It's also within IETF. Like, how do our different pieces fit together? How does the service model fit with traffic engineering, or how all these things relate to, say, deterministic networking? So many questions, and now we can go to discussion.
Dan Bogdanovic. So when you mentioned the SLAs, there's a slippery slope with that. You have technical SLAs and you have business SLAs. And the question is, which ones do we want to define? And we had the discussion already before, and we didn't really know the correlations between technical and the business ones. And then we said, well, we will just leave it inside the service model, but we will not go into the KPIs and then try to map it into that. So this is one thing where we would need much more input from the operators, and maybe reach out to Nano, Gripe, Peach, and get input on that from there, because they know that, and that's something, if you want to work with them, this where we will have to create some new liaisons in order to be able to exchange that information.
And that's a very good point. I just wanted to say that when I mentioned SLAs, I was mostly thinking SLAs in the context of some industry alignment across some terminology and concepts, which would be referenced by SLAs, but not that we necessarily have to develop SLA standards here at the IETF. If that may be an easier task than developing that.
Yeah. Okay. So, and then on.
Hi. Hello. Hi. Stuart Playman, UCL. I have a couple of confusions that have been brought up by your slide set, which I wonder if you could clear up for me. You mentioned virtualization quite a lot. You mentioned VPN quite a lot, and you mentioned slicing quite a lot. And it wasn't clear to me if, in your mind, these are fully interchangeable, or you see them as separate concepts somehow. That's my first point. My second point, confusion. The second one is that you start off by saying there are some frustrations, people not building on what's there. And you're near the end, you say, well, this cross-domain stuff is very difficult, beware. But for many people, slicing is the cross-domain issue as opposed to the single domain elements that already exist. So I wondered, again, you could try and clear up any confusion I've got from that.
Yeah, so there was some noise, so I had trouble hearing all of the second part. But for the first part, I think the terms that I used are somewhat diffuse, and in particular, the 5G slicing term has many possible meanings. So I couldn't possibly stand here and claim that they are exactly the same thing. I think I'm trying to speak about a general topic area that, in my mind, is network virtualization, but it also associates to various kinds of resource reservations and service guarantees, and as well as then more sort of, in my mind, business concepts like network slicing.
The second one was about the cross-domain issue. I'm saying that for many people, slicing is the manifestation of the cross-domain issue. In your slides, you thought this was an area that everyone should be aware of. So I wonder if you could clear it up.
I think there are many people who think that exactly like you say, that the cross-domain is the thing that we need to do. I was just basically standing here and saying a warning that, yeah, that's okay, but that's hard. I wasn't saying that we shouldn't do it, but it is demanding. We should be aware of that. Or you know, maybe I'm wrong and it's actually easy and we already have solved 90% of it. Thanks.
Adrian Farrell, welcome back, Yari. Can you get back one slide? Yeah, so two little things jumped out on this. The third bullet, the ability to specify about the underlying VPN or API. Were you thinking of this as specify at the service level or at the network level?
Set one click this.
I'll be talking as Carl and not as working picture. So interdomain in general is not a new issue to IETF. We've been doing this at layer 1, layer 2, and layer 3 for the last 20 years. What we haven't been doing is interdomain connectivity across layers. Right, so this yet to be solved. Back to your question, if service provider is network, so network has service model, or API exposed by service model might be the right level to interact. If it goes upper, maybe interacting with radio system, service level APIs could be too detailed. So we just need to figure out right level of abstraction that's going to be exposed to upper system, that's northbound.
Okay, so there may be like a meta bullet to this one, which is work out the right level of abstraction and then specify. Right.
So if you look at today's work at IETF, we see service model layer interacting with network layer, interacting with device layer. So well-established terminology done in ACT, defined in the CTN architecture, done in TSC, come some other working group. For this particular use case, it feels like right level of abstraction. For complete slice, it might not be yet to figure out how to properly do and do the mapping between them. And this goes kind of to more abstract things such as graph theory. How do you provide complete connectivity graph, walking it up and down, being recursive? It's much more complicated than building single layer model and saying it's going to work for VPN. Sure it does, but imagine you've got something on top, something below that's recursive.
And then on the fifth bullet, terminology would be brilliant, especially aligned terminology. And I'd love to see a short, pithy, concise definition of network slicing. And I could even sell you one, but it may be a tar pit trying to define network slicing.
Yeah, when I said we should define some terms, I was actually thinking of some other more fundamental, maybe smaller pieces of terminology than slicing. I think it's. I agree with you. It would be difficult to define that, and not only because it's sort of tied up with other people's definitions.
I wanted to cut the line. I was just about to jump in to cut the line because we. I'm going to cut the line at the 3 people who were at the mic earlier on. Okay.
Last 4 people.
Okay.
Okay.
Yeah. Okay. So my name is Georg Meyer. I'm the 3GPP liaison person to IETF. And I mean, we had a lot of discussion on slicing at the last IETF, also in regards or in relation with 3GPP. I think discussing this in this way is a very good approach. It's very open and it gives us possibility to bring things in. In 3GPP, I can only say, you know, we have the tight schedule. We see that the slicing issue affects, as we have really an end-to-end view to slicing. So whenever you provide a slice, it's an end-to-end network, at least a logical one. This affects the radio, this affects the core network, and this also affects the operation and maintenance. These are three areas that are capable of talking with each other in our standards body, but it's not always the easiest. So we need to sort out the internal communication needs already. How much we can participate in that work soon is a question I'm not able to answer. And I think you were at some of the last meetings, you might have seen the rush some people are in. On the technologies that are used, because this was a question before, I think virtualization definitely is something that has a major part there, but also we look at mobile edge computing, for example. So this is something we need to take also in consideration. Yeah, I think that's all I want to say on this. Thanks.
Thank you.
Jidong from Huawei. First, I'd like to say that a good point is about the tailored network and the general purpose network, because recently there's some emerging service which will require guaranteed or more predictable performance, and they will like to be carried in a common infrastructure network, and together with the existing services we have. So we need to reconsider this, whether general or the tailored network. And another point is it will be really important and useful to consider this network slicing in different layers of the network, both the management plane, control plane, and the underlayer data plane, because we need to see what the existing network technology can provide, and is there any gaps in any layers so we can put them together.
Yes, I agree. Thank you.
Hi, my name is George Karagianis, and I'm working for Huawei. Yari, thanks for the presentation. It was a very good one. I have a question regarding the fifth bullet there. I assume that the alignment of terminology and concepts is not only between industries, but also SDOs. So I assume that that is also the case. So if that is the case, then looking to 3GPP, 3GPP is very much focusing on network slicing. Of course, maybe the terminology will be different, but there are some concepts that are very similar. And my question is related to the first bullet, data models. As you might know, 3GPP SA5 is working on templates, so slicing templates that are somehow, similar to probably what we like to do with the data models. So how could we ensure that, that we are not competing with the slicing templates that 3GPP SA5 is doing?
So I wouldn't say that their templates are data models. You can compare them to Tosca manifestos, right?
Depends
it's
on
more service description of data model.
Yeah.
So there's work to be done to align API we expose up to service request and management coming down. So they're not doing the same thing.
No, but the concept is the same.
I would disagree with you, but we can take it offline. The point being, again, we need to speak same language in order to make work, and partially idea behind this draft is to provide enough thinking to people who are not familiar with IETF technologies to understand what can be done and reuse existing terminology and technology rather than trying to reinvent the wheel.
Okay. Yeah, and it's also important that we can point to sort of other people's pieces of technology, like the template that you were mentioning, in a future revision of the document. So we'll put that in. Thank you.
To add, we expect a lot of inter-SDO communication. So lifecycle management, that's a thing we've been notoriously bad at. It's happening someplace else, and very important to us. Someone has to manage lifecycle, resource allocation, deallocation of the CRUD operations across network users like for example.
Alex Callis from University College London. I'm very encouraged by this presentation. With my academic hat, I would like to make some addition to your survey of what happened so far. But also I have also a little question which I would like you to answer.
Yeah. So just to say on the addition that those would be really much appreciated. So
okay,
please contribute.
So, one way to look at this is definitely virtualizing systems, and probably initially this came from program networks. That's 20 years at IETF. Forces group practically produced enough to show this is possible to segment, or if you want, partition your resources for a purpose. And it's still something to think about. Second, obviously, SDN enable networks enable partitioning the resources of the network dynamically, in some sense, for a purpose of managing flows, obviously, not more for others. And that's an additional element. However, there is probably around 120 methods to build virtual networks based on surveys done in academic world. And that's basically what happened so far. So it's a time to move, as you said, bottom up, linked to the top down, not one or the other. And that's where I would like to tease you a bit to highlight a little difference from virtualization, where slices are substantially different, conceptually and practically, which is basically related to the fact that slices are driven by services. In other words, for a slice, you need specialized infrastructure to support that service well. It's not good enough to have best effort. And in addition, to do that, obviously you need to partition resources. There's not a question about it, including the non-connectivity resources, which are important, like computation, storage, and obviously to take into account service functions and management functions together.
So I need to jump in here. We need to wrap up this question, and also the microphones I closed after him for the questions. So
my question is, if I'm allowed to say, because I understand that this session had half an hour compared with other session last time, which had 10 minutes. So if you're allowed to ask the question, I'll ask. Otherwise, not. Shall I ask the question?
Complete your question, yes, and then, but the microphones are closed because we need to continue the session and not take away from other
My kind request is, where do you see this additional work, which covers not only partitioning of different type of resources, but also services as a package helping this? Because I didn't see that explicit in your future work.
Yeah, that's a good point, and I certainly agree with everything that you observed earlier. At this point, I don't have an answer, but I think step one is figure out where we are, and step two is figure out what's missing from where we want to go, and then we'll have to figure out are these IETF PCs or somebody else does them and so forth. But let's figure out what we have first. So that's what we're doing.
Maybe we have more discussion offline.
Yes,
yes,
absolutely.
And please, I'm sure Yari and Jeff would be interested in hearing your input offline, but we need to move on with the agenda.
So we'll discuss this further on the list of this working group. So be happy to receive feedback and further discussion. Thank you.
Thank you, Yari. This is work in progress, so we'll be updating work on an ongoing basis, and we'll always welcome your input, your comments, and we're not trying to define anything. It's really work to help other people to understand what IETF is doing, what's available, and what could be done.
Okay. So go ahead and put accept Xiaozhan. So the next presentation is from Xiaozhan Ding, who will be presenting remotely. Now, is this to cut off the presenter or to allow him in? Yes. Let's see.
Hello, everyone.
Try it. Yeah, there we go.
Can you hear me?
Yes, hold on a moment. We are getting your slides up.
So, can I start? Hello?
Yes. Go.
Yes.
If you can hear me,
okay,
go ahead
let's
and
start
start
my
presenting.
presentation. Okay, this work is a new work. So the first is a problem. So for ARP protocol, several vendors have their own provide YARN modules to implement the ARP functions, such as Cisco, Juniper, and Huawei. Such provide YARN module can well applied onto their own devices. However, due to the different function of devices, provide YARN module is hard to use across devices and cannot meet the demand of common requirements of user. So in this case, imagine a scenario that a service provider manages the thousands of devices, and these devices are from many different vendors. It must be a disaster if there is no way to control these devices in a standard way. So the solution can be extract some common properties within devices implementing the ARP. So this method has two meanings. First one is provide a unique identifier for ARP configuration function. For example, the agent sometimes in the provided module it called the timeout or the expand time. So it depends will summarize it in a Unicode identifier, and the similar is the interval is sometimes called the detect interval or the ARP interval. So we can give a unique name so the user cannot be confused by these similar names. And this method can provide the common properties. For example, the static LRP entry and the dynamic LRP entries, also the proxy LRP. So this function is well defined in LRP protocol. Next please. Here in our draft, we summarize the 4 features of ARP configuration functions. The static ARP entry, it performs this task is to define the static mapping between an ARP address and a MSC address of the host that do not support dynamic address resolution protocol. So, however, because most hosts support dynamic address resolution, so defining the static IP cache entries is usually not required. And the second is dynamic learning of IP entry. It is the host and the switch itself has a function, and the default state of the device of ARP learning dynamic. It do not need do not need to use the command to start this feature. However, according to the network needs, users can adjust some parameters of dynamic ARP. The proxy ARP it is enabled by default, so perform this task to disable the proxy ARP on an interface. And the finally is the gratuitous ARP. It is a request to help detect the duplicate IP addresses. So next page, please. So we can see the tree diagram. The first is a container IP static table. It lists of static IP configurations. Expand time is the lift. So is the lift. It describes the aging time of the dynamic IP entry. Also, the IP name is the lift. It describes the whether a dynamic IP learning is disabled, and it's enabled by default. And also the IP proxy it described. It is enabled by default. And we have the grouping of IP prop. So this grouping describes the common configuration of IP prop. So the leaf prop interval means the interval for detecting the dynamic IP entries, and the prop time is the number of aging prop attempts for dynamic IP entry. And the unicast means whether use unicast mode to send an IP aging prop message. Next step is here list some static features. There are two containers, the IP table. A table lists some IP entries that can be queried. Query IP entries including static, dynamic, and interface-based IP entries. It has a VRF name. VRF name is the name of a VPN instance to which a IP entry belongs. And the container IP statistics is a list of IP package statistics. It has two subparts, the global and the local. So this means you can display the IP statistic globally or for a specified interface. Okay, next step. So we next steps. First one is align with other models. So here we summarize. Here we mention a comment from Alex. Alex from the mail list. So there were three questions. The first is about the publishing model IETF IP. It also called IFC7277. It overlaps the data being provided in this module. So for this question, we can separate it into two parts. The first part is for interface IPv4 label for this container. It does describe the entries of mapping from IPv4 address to link layer addresses. It is similar to.
Can I interrupt for a moment? I'm not sure we understood which model this is conflicting with. I don't think I was able to hear that well. Could you?
Yeah.
You mentioned a specific model that this was in conflict with, that you've gotten feedback. I didn't understand the name of that model and where it is. If you could repeat that would be helpful.
IFC7277 is this model, the IETF IP.
So it's not sure that clear that I'm going to be able that we'll be able to communicate well over the Meet Echo link here right now. Do you have a comment, AC?
Yes, I'm very familiar with the models. It's the interface IP model he's referring to.
Okay.
It's 7277.
Okay.
7277.
Okay.
And I was able to, from the context, glean that, not from understanding it perfectly.
Okay. So so this is Chris Bowers speaking, one of the working group chairs, and I wanted to just kind of jump in on. I think this model is actually a pretty good fit for RTGWG. That is, we're tasked with doing Yang models for standards and work for which there are that's in the routing area, but there are no other working groups specifically tasked with that. Now, technically, one might think of ARP as not being in the routing area, but in the int area. But the aspects of this is really more service, proxy ARP and other features that are going on routers, large-scale devices, not the ARP functionality necessarily on a host. That's sort of fixed, but you're really talking about, I think, in this draft more the the ARP functionality, the sort of complex ARP functionality you do on routers. So I think it's a good fit to, eventually consider for adoption in the routing area working group. I'm not in a position to judge consensus on that or anything yet, but I think it's a good, you've brought it to the right place in presenting it here. It might actually facilitate people in the routing area paying attention to it more, to change the name to, drafting RTGWG, just put RTGWG instead of netmod in this, and that'll get it automatically brought to the attention of people in RTGWG.
Okay.
So you can go on and respond to that, but I just wanted to jump in and say that.
And for the interface interface IPv4 neighbor for this container, the list describes the LP cache. So that is, we can obtain the LP entries for interface. However, in our LP tables, we can not only obtain the LP entries for interface, we also can obtain the LP entries for VPN. The VPN, we use the VIF name as the key. So for the second comment, I suggest of use augment for the container IETF in interfaces of IFC 7223, and we think it is also a good question. The argument can be used to reflect the module of the possible interface and interface in the IFC 7223. And the last comment is about the IETF network instances for implementing the VIF. As discussed in the first part, VIF director entry, we can delete it in ARP static tables and container. So best of the
So can I jump in here? So we're running out of time for this this presentation, but it would be good to take the the comments and your potential responses to them, and at this point it's an individual draft. So go ahead and make the changes that you think are appropriate to respond to these. Post that draft and bring it to the attention of RTGWG.
Okay.
Discuss these, describe the changes on the list, and I think, and describe the sort of comments that you're addressing that motivated those changes.
And last comment, please make sure your draft is compliant with IETF advisory on new architecture for data store. Any new data model should comply to this model.
Alia Atlas. Thank you for the draft. Just a point of detail, since ARP is traditionally in the int area and not routing, I want to circle with the int IDs to see what the right place to put this is. But thank you for doing the work.
Hi all. This draft is basically version 0, but it has a little bit of history involved. So we presented this draft in IETF 93 with as a point-to-point BFD solution, and at the same time another use case was presented with a point-to-multipoint BFD. So in that meeting we decided we'll merge both the drafts. And in the next IETF 95, we presented the version 4, including certain comments. And after that, there was a little bit of, we got an IPR issue from Ericsson. That is where the working committee decided that we should stop working on the draft and we abandoned it. And now since that IPR is open and we have moved out of that point to multi-point BFD use case from this draft and we have brought the new draft in picture. So I'll just, in order to make sure that everyone is in the sync with the draft. So this draft was meant for, if you see nowadays in the data centers and other world, the VRRP detection usually goes with a sub-second timers. So if we implement VRRP in the control plane, those sub-second timers, they become a bit aggressive and they can cause CPU delays and all those things. So if it uses the BFD, which is meant to serve that purpose, then we can move forward. But in order to use the BFD, VRRP has some intrinsic limitations where VRRP itself, only the master VRRP, it sends out the packet, whereas the backups, they don't know about the backups. As a result of which, master also they don't send out a packet, so master also don't know about the backups. Whereas for the BFD to work on, BFD needs the IP address of the source and destination. That is where we brought this draft to bring a new advert packet type. Along with it, we brought a new thing called peer-to-peer peer learning model, where once we will receive the packets from the backup, we will decide what can be the critical backup, and based on that, we will form a session which will be known as the critical BFD session. So the table will look like all the peer nodes, they will interact with each other, and they will form a table based on the highest priority backup and the master, they will form a critical point BFD session. If the critical BFD session goes down, the other sessions, they can take over. So in this draft, what we have done, we have brought all the comments which Jeff has given, Mac and Chris and Venkata, they have given us comments on this. So with this draft, we are bringing an extension to the VRP protocol where we are adding a new packet type. Then we are defining a peer learning model and defining a critical BFD session for the faster convergence. Also with this, since we are bringing a new advert packet type, as a result of which we are updating the VRRP protocol state machine to accommodate 2 new timers. Then we have considered a lot of things like security, the scalability considerations that backup should not send the advert at the same time. They should set at a lower frequency, or the operational considerations like VRRP should interface only with BFD when BFD is capable to send the aggressive packets. So with this draft, we have removed the P2MP use case and updated the INA considerations to accommodate the new packet type. That's all with this draft. And now we are open for your comments, or we can go to the working committee for the adoption of this. Any questions?
So Chris Bowers here. So since we had reached the point of working group adoption, and I think consensus was to adopt the other draft except for the IPR issues. I think, well, I haven't read this draft yet, so I need to, I'll finish this. Mm-hmm. So I need to look at it, but I think we'll do a quick evaluation and then, poll for the consensus for working group adoption. And we can have that discussion in that poll, or Greg may have some other points to bring up.
I'm very glad and I appreciate your consideration. I know that IPR issue is very sensitive at IETF, and I share that concern. I just want to reiterate what was said in presentation in the first session when we presented updated document that offers believe, again, to the best of our knowledge, that their stated disclosed IPR is not cover new updated version entirely. I try not to be very legal minded.
Right. So as this is a new draft, right? Part of the working group adoption poll, and I guess in this case, we'll separate the adoption poll and the IPR poll. Okay, this is a new draft, and if there is any IPR that applies to this new draft, the point-to-point draft, then we expect it to already be disclosed. And then we'll require all the authors to attest to that, or to.
Yes. Well, the thing is that what happened, I don't know. I think it was quite clear stated in this presentation, that the drafts now split again. So we have point-to-point separate draft for point-to-multipoint BFD draft, and IPR was disclosed against old version of proposed mechanism using point-to-multipoint BFD in VRRP.
Yes, I understand that. And so now that the drafts are split, I expect that the point-to-point draft will not have any IPR disclosed against it. If that is not the case, then...
Yes, as far as my knowledge, because I know other, we have already discussed about it, and we don't have any IPR associated with it, neither is Brocade. And as far as I know, Greg also knows there is no...
So if that was the point of separating the drafts again, like reseparating them, then I would expect that to be the case. If it's not, then please disclose IPR on this draft if it exists.
Okay. I think that might be okay. We can take it offline, because there is one problem with once IPR was disclosed, and even it's not longer applicable to the draft. To the best of my knowledge, there is no mechanism to withdraw that disclosure.
Well, we have effectively withdrawn the disclosure by creating a new draft. The draft was related to a previous draft. This is a new draft. It will have no IPR disclosed against it. Presumably, if that remains the case, then we've communicated to the working group we followed, I believe, the correct intention here. Lou Berger, our IPR consultant, will give us some comments on that as well.
Lou Berger loved being a process one. Let me just say, it's such fun. Yeah. It's my understanding that if you create a draft that is derivative of another, you do a market replace, because that shows that there's a derivation and that inherits the IPR. Just because as soon as you make it derivative, you've inherited the IPR disclosure.
Yeah, but we haven't done anything to do that, I believe, right? I mean,
I thought I heard you say you've created a new draft based on another draft.
So they created a new draft with the explicit goal of separating out the part of the draft that had IPR against it.
I think you can say that the working group believes the IPR doesn't apply. I don't think you can say that there's no IPR disclosure against it.
I disagree with that. So, I mean, we can look at how the data tracker works in this case. And in any case, we can write an explanation about what the working group understands the situation to be.
I would suggest that you have an agreement here that you don't think it applies, and move on and not document anything more than this is a working group document you'd like to progress.
That's right.
So I don't think you should get hung up on documenting a working group's decision about an IPR you think may or may not apply, because frankly, that's for lawyers to decide. We can't.
Oh, okay. Yes, I think we agree.
This is Don Leeslake with Huawei. Whoever submitted the disclosure can submit an update to the disclosure saying it doesn't apply anymore. So there's no way to cause there not to be any disclosure at all associated with it. But the disclosure associated with it can be one that says that the previous disclosures are no longer applicable and there is no IPR for that declarer.
Yeah. I think it's quite complicated by employment changes and so on. And we'll discuss it and figure out a path forward. We shouldn't, we're trying to do the right thing here in both cases. So I think we can come up with a solution.
Thank you.
Stuart Bryant.
Right, so this is an update on the work we've been doing on enhanced VPNs or VPN Plus. That's right, thank you. It's there. So VPNs have been widely deployed to support multi-tenancy in public operator networks, right? I mean, that's what they're one of the things they're well known for. They're now expected to provide emerging new services and new customers with more stringent performance requirements, for example, bandwidth, latency, and jitter on this shared infrastructure. So what we think we need to do is to provide an enhanced VPN that needs to enable multiple customers with quite demanding now shared demanding services on a shared network, ensure high performance with reasonable cost and scalability. And the reason we're doing this is to underpin 5G and network slicing. But we think there are other applications for it as well. So what are the requirements? We think the requirements are isolation between the VPNs, greater isolation than just simple routing table separation. Guaranteed performance, bounded packet loss, latency, and jitter for critical services. Integration between the overlay and the underlay in order to achieve some of these performance guarantees. We're going to need to support network and service functions, we think, with the same sort of guarantees. In particular, the hardest one, in my view anyway, is the need to add, modify, and delete services without disrupting other services. So the approach we've been using is a layered architecture. So we start at the bottom, we have the physics. We then divide up the resources and make separate resource units available on the routers and on the links. And then we allocate in the overlay those resources to a particular customer VPN. So at the top we've got a VPN Plus instance, then we've got the underlay, and then at the bottom we've got the physics. And we think we're going to have to do that isolation. So traditional overlay mechanisms, each overlay network can have its own router and forwarding table and separate address space. Overlays compete for resources with each other unless every connection in the overlay is mapped to a dedicated traffic engineered LSP for bandwidth reservations. The problems with this is that as we increase the number of overlay tenants asking for guaranteed performance, this results in an increase in the number of traffic engineered LSPs, which ultimately we believe leads to scalability problems, and that's the segment routing argument. Bandwidth reservation, in our view, is not enough for the degree of latency that we're being asked for. So one of the we need to look at what technologies we've got in the cupboard that we might use. One of the ones we looked at was simple multi-topology routing. So that provides customized network topologies for different services, allows the mapping of data packets to specific topologies. Rather, the mapping of data packets to specific topologies is not addressed per se by the MTR design. So we need to use ACLs to do it, which we fear is too complex, and they will scale badly as well. But MTR together with segment routing looks like a very good candidate for our solution. So what are the problems? Well, MTR is really still a best effort forwarding service, and adding it with segment routing doesn't entirely solve the problem, because segment routing doesn't provide resource reservation, which is necessary for the performance guarantee. Also, if we build our control plane based on MTR, we think we hit a topology ID limit problem. Greg?
Hi, Greg Mirsky. Okay. We had the discussion, very interesting discussion with Yuri. Unfortunately, we didn't have much time. I just want to point is that traffic engineering, traffic steering, not necessarily has to deliver low latency and low packet loss.
That's exactly our concern, right? That it's not enough of it. Not only is there a sort of competition.
Yeah, but it can be provided by the physical layer. for example, FlexE.
Right. Well, the way we see things, I think, is that there are two candidate solutions. FlexE is one packet solution, but that doesn't give you the statistical multiplexing advantage that, yes? So you burn through your bandwidth by hard allocating it to services, but you do get the best, out of the physics you can get in a packet network.
TDM, yes.
So we think this is, we've got a slide in a moment, we think we need a solution in the packet domain, and we think that probably something based on deterministic networking would be the right way to go.
Okay, if I may, I would probably say we should try to look for the solution, and if we find one, we're good. If not, then there is no solution, and we can solve it other way.
Right, but I don't think deterministic networking itself is good enough. Well, let me get to the deterministic network slide. So we think we need to extend segment routing to provide resource reservation in a way it doesn't have at the moment. So we need per hop instead of per path reservation. Follow the paradigm of SR. Following the paradigm of SR achieves resource reservation with much less state in our view. Controller-based reservations, we probably need to build do this through an SDN type system, a controller-based system. Dedicated SIDs used to partition links and node resources. We need to use a much finer grained system than we had before. So let's look at the next slide. So this is the proposed mechanism. I think I've shown this before. I know I've shown this before. So this is showing, you can see the underlying physics. Then we carve this up into the virtual networks using SIDs and link SIDs per slice or per a VPN instance, enhanced VPN instance, and then we can build VPNs, as you can see on the right, using that technology. And we can do this for both strict path, and we can do it when all the resources are absolutely dedicated to the packet. We can do it for loose path, but loose path has got a number of interesting issues. So this allows us to dedicate the resource to the VPN, but not to the packet. And so if aggregation's good, then great, but we don't think you can get the best out of the system always. DetNet. So the performance goals of DetNet are almost identical to some of the performance goals of VPN Plus. No packet drop due to congestion, low latency, but in particular an upper bound of the latency. DetNet currently runs over the data plane the substrate is unmodified from the existing substrates. The DetNet people are going to put, are talking about changing the queuing model. There was some sort of discussion on that today, but it's essentially running over an unmodified substrate. Multi-tenancy, however, is not a feature of deterministic network.
Captain Sir, I have a question about terminology.
Yep.
So if you look at DetNet, they specifically provide point-to-point service.
Yes.
You call this virtual network, wouldn't call it class of service or something really relevant to the way network behave, provide better description of what it does. Because you cannot do multi-point connectivity here, right? If you use segment routing.
Sorry, I didn't hear the question.
It has to be point-to-point if virtual network context is segment routing driven. So maybe another name would be better to provide through.
Okay, yes. I think we're thinking of label stacking, I suppose, is what we're thinking of doing.
Maybe another name would be.
Yeah, we may need a more generic name for the technology. So multi-tenancy concerns us because multi-tenancy is not fundamental to deterministic network, and yet we need the sort of the characteristics of multi-tenancy in terms of the much harder isolation. So one of the things we can do is to create an instance and then run DetNet over it, but we don't think we can do it the other way round. So one of the the next phase of the project is to work out whether VPN Plus extends DetNet, or whether it uses DetNet in an enhanced way, or whether VPN Plus needs to move some of the current DetNet boundaries slightly. We need to integrate with service function chains, because service function chains are an integral part of the types of network that this is going into. So we're going to need to look for a holistic sort of approach to both VPN Plus and network slicing. Whether we do this with segment routing, which is one of the candidates, or whether actually it forces us to revisit that decision, is the next thing we need to study. Let's get to the two final sort of concerns. All right, so scalability. When we move from best effort guaranteed performance, we need to provide greater integration, in our view, with the underlay. So we can either introduce state into the packet, which is the SR or the label stacking approach, or we can introduce state into the network, which is kind of the RSVP or the MPLS TP approach, or we can provide some hybrid. And I'm thinking that we're probably going to need a hybrid to try and get the sort of state under control and yet get the control that we need in the design. Now here's the last and really quite interesting one. In order to get hard slicing, you need to do disruption-free reconfiguration of your network. That is to say, it's quite easy to add a service, it's quite easy to take another service away, but modifying a service is going to intrinsically affect the paths that goes on, and the net result is going to be a potential disruption to quite sensitive traffic. So SR is quite good at doing that, at least strict SR is quite good at doing that. Loose paths, though, are still subject to looping unless you have some convergence controlled technology, such as one of the IPFRR techniques. But really, one of the hardest problems is to figure out how we do disruption-free defragmentation of the network. In other words, how we recover the resources without affecting any of the other services, because you can't move anything around without changing the delay and jitter characteristics. So that's as far as our thinking's got this time. We're always interested in questions.
Ahmed Bashandi, Cisco Systems. Can you come back to the slide that had these colors? No, the previous one. Yeah.
That one?
So let's take one of the tubes here, and let's take the blue slice, if I
Yep.
use the term. If 10 services are competing for this blue slice, how
No,
do you
no, nothing competes for the blue slice. That's the whole point. You have to reserve the resources that the blue slice wants. So you may have to do some interesting queue management, for
Okay,
example.
so which means that for each and every service, you have to have a slice on each and every link.
It depends. It depends on whether there's enough aggregated resource for you not to do it. So as you go through the network, you'll move from areas where it's really quite difficult and you do have competition, in which case you will have to reserve resources.
So you're defeating the purpose of segment routing, which means you are per service, you are putting state in the network. I am kind of missing. So let's say I have 100 services.
Yep.
In order for them not to compete, I need to create 100 slices.
Yep.
On the top link. If I have 1,000, I need to create 1,000 slices. So I end up doing RSVP, right?
No, you don't end up with RSVP because you can use the techniques that you're developing in SR to do your state distribution.
So why do I need this if I can do it in SR? I'm kind of confused. So this is, I can do SR, which means I can...
SR doesn't have state resort, doesn't have state reservation at the moment, does it?
In order to divide this into 3 colors, I need to have state at the node that says color blue, color
yes, but
green,
I don't commit the state until I actually use it.
How do I do this? I need to have something sitting on the
Well,
router
clearly
that
you're
says-
going to need to provide the SID list to the ingress nodes.
I'm not talking about SID list. I'm talking about a simple scenario. I have 1,000 services.
Yep.
They are competing. I need to create 1,000 colors on this link. Okay. You're saying no, you don't. But then you say go ahead and use the label stacking techniques in SR. So why do I need colors. I can use the label stacking without having colors.
I didn't
you see
say
where
that.
my point is? It is really not clear how you're integrating both of them.
Maybe I can answer that. Jedong from Huawei. Yeah, basically, this kind of mechanism is for the emerging new services which require the much high demand on the performance guarantee. So for this kind of service, you need to reserve the resource on the each hop and link. But for the normal service, you still can aggregate state into one seed or no seed or adjacent seed. Basically, this is a mechanism to provide the resource reservation on the per hop basis, and you can still aggregate, do the aggregation. So this is
So you can
both.
you can pop into and out of aggregation depending on the relative load of the system, of course.
Right.
But by using a SID list, you can RSVP would require a single label that went end to end, right? That you swap it at each node, but it would have to be one per service. This allows you to have fewer because if you can share a source, then you don't need to have a dedicated label for it. But when you pop into a more contended area, then you pop down to the label that gives a more specific resource.
Hi, Lou Berger. What do you think is the new work here? By the way, I should start out by saying I think this is really good stuff.
Right.
I think it's needed, but I want to understand what you think is new.
That's what we're in the process of working out, because we don't want to invent anything we don't need to. So this is sort of a different slant on the stuff that Yara is doing. That is to say, look at the technologies we've got, see what we need to add to it, and see what we need to build some working models, and then figure out what the missing bits are.
Okay. So if you're doing like traffic engineering architecture work,
Yep.
there's a working group for that. If you are thinking about how to leave some state behind with traffic engineered SR, turns out there's a document on that being adopted inside MPLS. So you can go there and do that. If you're doing something .NET specific, you can go there, although I don't think you have anything that's .NET specific per se. So I hope you don't go there, but you could. I think this is good stuff. It's just not clear to me if it should be discussed in this working group.
Well, so somewhere we have to put it all together. That's part of the problem.
So
That
we
understand
do
what
traffic engineering architecture in the traffic engineering architecture working group. So you go there. From what you're talking about, it sounds like you just want to use the stuff that MPLS is doing. So maybe when you figure out what you want to do, you just go use that new draft.
So if I may, after reading the draft, and you could confirm it, my understanding is that he's trying to infer particular type of behavior based on value of the label.
Yep.
So please be clear. This is my understanding of the draft.
Garbadabra Cisco Systems. So I have presented service chaining with segment routing and the working group where it is. It's a solution which we believe is flexible enough. And I have the same comment as Lou. I'm failing to still understand what is new here. It's kind of like taking different ideas from different technologies and creating a state in the network which we don't really need. And it just breaks down the overall idea about being dynamic enough if a network changes and do that source-based routing. Because you threw all these ideas about service chaining, network allocation, tying it on together with 5G slicing. I didn't see a comprehensive view of how it is solving that problem.
Well, so we're trying to show how we put the components together.
Tom is Rahim Marvel. So a question of clarification. You said that bandwidth resource reservation alone isn't enough. So can you repeat what you meant, what is missing here? Why bandwidth isn't enough?
Sorry, why bandwidth isn't enough? Because I think we need bandwidth isn't enough because you've got to stop the services competing with each other in order not to screw up the latency. So maybe we can do better flow filtering, as was discussed in deterministic network earlier on. But without that, we do need to have some separation of the traffic, or the packets will bump into each other. And this is really about a much harder degree of isolation than we're normally used to.
Greg DZT. I think that what Yara mentioned, and that will be very helpful if we set a common dictionary that already being used in other areas that work on network slicing. For example, and that's not network slicing specific, but it's with SDN, there is such thing as a life cycle orchestration. So what we talk about when commission or decommission entity on network slice, it's a part of the life cycle. So you don't throw it and hope that it works. So you have a certain process that you need to follow. You can characterize this process for the data model and use it. And there is part of this process is a service activation testing. In terms of what we talk and continue talked on DetNet, yes, in some scenarios, especially where there is a very stringent requirements to latency and jitter and packet loss, CAC on a bandwidth on the edge may not be sufficient. That's what answer to tell. And again, I think that there might be that we'll not find their satisfactory technology in the packet with the statistical multiplexing that will address these requirements of ultra-reliable and low latency communication. Because other scenarios for network slicing, they don't have the strict requirements. I would like us to understand that network slicing not necessarily set forth very stringent requirements. There are massive, enhanced massive broadband that is just the broadband in the best effort. Massive IoT, yes, it has industrial IoT, but that will go into this ultra-reliable scenario.
So I agree with you. What I haven't been showing on here is the sort of background traffic, which I'm going to assume is going to suck up any bandwidth that's still there. I've just been focusing on the stuff that needs hard limits.
Yeah, right. So that I agree, and I would like us either just to agree in that will be put to rest. We understand this is only part of net slicing use cases.
It's not even necessarily part of net slicing, of course. I mean, I think this is useful regardless of whatever fate net slicing.
Yes, right. Okay, but let's agree that stringent requirements only a part of use cases.
Yes.
Daniele Ceccarelli. Well, I tend to agree with what Lou said in the sense that, well, this is traffic engineering, so probably discussing this work in TIS would be appropriate. In addition to that, there is a work going on in TIS which tries to find a general approach for this problem, which is binding a service to a given underlying infrastructure. And in my opinion, this work, provided that I believe it's super useful, should be independent from what is the underlay, in the sense that it shouldn't be applicable only to segment routing or only to that. It should be independent on what is below, in the sense that if you have an MPLS-T tunnel, why not finding a solution for that problem too?
So in terms of building models and configuring it and all that sort of stuff, yes, you do need to be independent of the underlay, but I think that if they are real queues in the underlay that you're going to have to get to. So I don't see how the underlay has no role in the design.
I was mentioning the work that is being done in TIS now. There is a model that allows you to map a given VPN to a given tunnel. If you keep track of the number of services that you allocate against that tunnel, you can avoid situations in which there are congestions.
Only if you have the right smoothing properties going into them, and even then, I'm not 100% convinced about it, because it's still statistical.
And well, if you have a 100 gigabit tunnel and you make sure that no more than 100 gigabit of traffic is going to use that tunnel, you can avoid congestion.
Well, it all depends on the smoothing of the various users of the tunnel. If I'm trying to get my one packet through and I can tolerate 0 latency, I don't want to be waiting for all the other services that happen to get there in front of me. It all depends on the degree of isolation that people end up looking for.
Yeah, but if let's see if we agree on this. If you have a pipe of 100 gigabits and you make sure you don't shoot more than 100 gigabits on that pipe, there's no congestion, there's no delay, right?
Oh, right. So it's a fully reserved 100 gigabits for you.
No, I mean no. You can have multiple services, but the total amount of traffic generated by those services doesn't go beyond 100 gigabits.
I don't think that's good enough in the sort of ultra low latency because of the statistics of the system. That's what deterministic networking is looking at, for example.
Wim Hendricks, Nokia. I think this draft, there is two purposes of this draft in my view. One is to put it all together, right?
Yes.
I think the second thing, and this is where the discussion is about, is how do you do this resource allocation based on certain requirements?
And I haven't looked at the control plane at all.
Yes, yeah, I was going to, because I think that is the new thing potentially which is coming out of this work, right? And it's more into the MPLS/Teams. I don't have an opinion about that, but what you're actually going to introduce here is that if you have a virtual link which has specific resources like a .NET specific interface, you have the semantics in segment routing today to allocate a SIT and a JC SIT or whatever based on that virtual interface.
Right.
What you don't have today is that if you have an interface where you need dedicated queues on a physical link which is not virtually sliced, which is actually on a virtual link, that's where you potentially need to allocate new SITs for those particular resources which are to be used. And I think that is potentially the new work. The disadvantage of doing that is that you actually introduce more state, but that's the trade-off between.
I don't see any way of trading off.
Exactly. It's the trade-off based on what you want to achieve.
Yeah. Right. And then we have to trade off how much that state we want to move to the packet and how much we want to put into the signaling plane.
So my suggestion would be that you have one draft focusing on the overall solution, but you need to have a dedicated focus in either the MPLS or traffic engineering working group to actually focus on signaling and the allocation of those SITs and how you want to use them.
We agree.
So I'll take a turn. I think what you're trying to achieve is to show how a label could be used as metadata to derive particular behavior. Yes. This is the focus of the draft. It doesn't really introduce new functionality, as of now at least. So, yeah, I think as a working group, we should be looking at it as a solution to solve particular problem as of now, because there are implications with regards to control plane, in segment routing, all the path computation is happening offline, how it's going to be signaled, provisioned, and such and such. So it's a useful work, but I don't think at this point you are trying to define any new protocol extensions.
No, I'm trying to show how we put the solution together to see what bits are missing.
So
call up the bits we got.
2 more people at the line and then we cut it.
It seems to me, at least from what the discussion, that this whole thing is because you want to guarantee service for traffic that with a profile that has burstiness in it. Is my understanding correct?
Sorry, say that again, please.
It seems to me that this work, the primary purpose of this work is to be able to guarantee service for traffic that has burstiness in it. It is not a smooth traffic, right? Because if this is a discussion that I understood, and frankly, this has nothing to do with this. This is queuing theory. It's been around for, I don't know, 50, 60 years. It has nothing. It is not specific to VPN. It's not specific to segment routing. It's not specific to SFC. It's not specific to slicing. What we have in this draft is 4 terms. In addition, that is trying to solve a specific problem. So maybe we focus on the specific problem, remove all the terms that have nothing to do with it. After we solve the specific problem, then we decide what terms sit on top of it. Thank you.
Okay. Basically, this draft will just give an overall architecture of this whole solution. So it can contain some existing technologies, and it will potentially some new extensions for like a resource reservation for segment routing. So we think we show a whole picture here, and maybe next step we will give some more detail about the new extension. Okay.
So G is a co-author, so that's fine.
Gunther learned them.
Yeah. So mine is actually more like a clarification question on your slide 3, where you put the requirements up.
We're done.
That one?
3,
1,
3, 3.
2.
So something what I see missing here is like,
Which one do you want?
it's very hard to find slide 3. Huh?
That one? You said
So
slide
anyway, so one of the requirements what I'm missing here is to take into consideration some of the physical resources, like a certain node or a link, in case you want to provide a service which needs to send traffic over paths which cannot be separated from a layer 3 thing, for example. Like you want to send traffic on one end of a service over 2 different paths going over 2 sets of completely different components within the network. So the clarification question is like, is there any reason why you left it out, or is it something we should be considering?
So I'm getting a bit deaf. I couldn't quite hear what the specific question was. Sorry.
Take your thing out, maybe either. So in this set of requirements, what I am missing at this point in time, and there may be a very well reason for that, and that's the reason I'm asking the clarification question, is there is no requirement to take into account different physical resources in the network.
Okay, I'm going to have to cut this off here because we have only 10 minutes left in the session. We have one more presentation. We've already taken 5 minutes from that time. So let's move on.
Can I make one comment as
No.
chair? All right, I'll make
No,
it to the ADs.
take it to the list.
I'll make it to the ADs.
Yeah.
Thanks.
Hello everyone. From the agenda, maybe I can start my presentation. From the agenda, I'm lucky to be the last one to give the presentation, and I think it's very meaningful because it is the IETF 100, and this is the last session of the routing work group. As well, I think my topic is meaningful as well. My topic is about the information model of the control plane and user plane separation BNG device. My name is Gurong from China Mobile, and my co-authors are Victor, Michael, and Shu Junhu. Before going to the details of the information model, we have several questions to be answered. The first one is that why we need the CO separation BNG device and why we need the information model. The concept of the BNG device with control plane and user plane separation come from the operators. We think that the BNG device can be virtualized, such as some functions can be offloading to centralized processor, which can be deployed in a reconstructed data center. Considering of the BNG device, there are many functional modules in the device, such as the information management module and the routing and forwarding modules. When we're talking about the BNG device with the control plane and user plane separation, we mean that the BNG control plane focuses on the information management, such as the user's information and resource information, which can be distributed, centralized, and virtualized. while when we're talking about the BNG's forwarding or user plan, we think that it includes the forwarding and the routing modules they keep in the traditional BNG device. Due to the actual deployment in our network, we have found out that multiple vendors' device is now existed in the network. So we have the distributed user plan belonging to multiple vendors, and we have the unified control plan. Thus, we need the standardized management. That is the reason why we propose our information model of the BNG device with the control plan and user plan separation. The information model is going to present the attributes or information transmitted between the control plan and the user plan. And give the second question is why now we give out the information model? I think it is the right time to come up with the standard information model. The first important reason is that about the operator's implementation. We, China Mobile, have done the trial from last year in 7 provinces with the BNG device of the control plan and user plan separation for providing the home broadband service. Besides, we have also deployed the BNG device with the SIV separation in our NovaNet. NovaNet means the whole network based on the SDN and NFV technology. That is the most important reason why we need the standard information model. And besides, in other organizations, such as the Broadband Forum, many operators have agreed on this architecture of the BNG device with control plan and user plan separation. And we have started the project, see the project WT384, which is focusing on the architecture of the BNG device with CU separation. See, many operators now will agree on this architecture. And besides, the network management dataset architecture has been completed. See, which we can be referred to this architecture in our BNG device, because when a large number of users access into the internet, we need the control plan to be dynamic enough to handle all these users' access. We think it is the right time to come up with the CU separation information model. That is the reason why. Why now? And this is not the first time to present the CU separation BNG device information model. The information model is firstly introduced in IETF 98 in Chicago. We present the information model in interface to routing system work group. And later we modified the information model due to some comments. And in this IETF, after the discussion with the interface to routing service work group chairs and the AD, they think that we may not get sufficient review in the recent work group. So they suggest us to handle this work off to the routing work group. That is the reason why we're here. Besides this week, or Mondays this week, the CU separation protocol requirements are proposed also in the routing work group. So we think there are maybe some relationship with the information model and the CU separation protocol. But for short, we think the information model and the CU separation protocol are independent with each other. Comments?
Rob Wilson, Cisco, just a clarification question. You're talking here about an information model. Is it a Yang model you produced?
No, it's not the Yang model, only the information model.
Okay.
It contains some attributes and information.
Okay.
Maybe later we can use the Yang model or any other model, data models to carry these attributes.
Okay, fine. I think I was confused by the NMDA reference, which I think is more tied to data model than the information model.
So I2RS chair, the reason why we encourage them to do an information model is they're actually looking for the dynamic data store portion where they can
be there and then go away and not use the configuration model. So that's why they were first at IR2S, is they were one of the first dynamic data store candidates we were looking at. So that's why the NDMA and NDA reference was made, because they were actually working on it. When they do that, we suggested an informational model first, because we're still working through how all that works. We have the topology model, we have the RIB models. This was a new case. Notice that in the RIB model, we went for an info model as well. So that's why you've got that background, and that's why we sent it here. The reason it's here is because the IR2S is completing its work and trying to send its dynamic models to the other groups.
So let's take the last two questions here at the mic.
Dan Bogdanovic, when you're saying control plane separation in the BNG, are you also looking at the separation of the PPP, or because that's a control protocol?
Yeah.
For the access, or you're also talking about the routing separation and the functions that you were describing, like IP pool management, DHCP, radius. Those are management functions.
I can answer your question. In the BNG device, it's a control plane. It focuses on the information management, such as the PVPoE. This information is used by the control plane to communicate with the outside system, such as the radios and many other outside systems, DHCP. This is what the BNG control plane does. And
so the only thing
routing,
is, I understand. So you're talking in this case the DHCP VLAN example. So
yeah.
It would be good to clarify which functions, what you're doing where, because in what you're doing here, because I read the draft and I was confused and I was trying to figure out what's what.
And we have another draft related with the architecture. It's introduced in the architecture draft. Yeah.
Just a comment or question. So the DMM working group is actually working on an information as well as data models for control data separation of mobile gateways. I wouldn't be surprised if many of these attributes can be reused here. So please have a look at this pretty mature draft before you bring up something new.
You said the DMM working group.
DMM working group.
Okay.
Okay. The draft is draft IETF FPC CPDP version 9 at the moment.
Okay. And if you just post that to the RTGWG list, that would be good
that would be
to just kind of point that out in a nice way. Thanks.
Okay. The next is also the relationship with the COSP we presented on Monday's session. We think it is maybe independent with each other because the information model is protocol independent. It only contains the attributes and the informations which can be used as a compendium for the interface between the control plane and the user plane communication. The information model contains the rules and the entries generated by the control plane. We think the information model is a foundation. And based on the standard information model, then we can generate the corresponding data model or TOVs. And about the COSP, the protocol, it aims at finding a suitable protocol to carry the attributes or the information described in our information model. As we think that the recent protocols such as netconf or restconf is not sufficient enough to carry these attributes. So we want to find another suitable protocols or the alternative protocols to carry these attributes. That is the aim of the COSP design team. That's what they do. And the next step, if you are interested in this work, you can keep an eye on the mail list because we will show the demo of the BNG device with control plane and user plane separation in the next IETF hackathon. And if you are interested in that, you are welcome to join us. And last, please read the document and give us some feedback or comments if you are really interested in it. The next slide is about the overview of the model. This is just the information model. In the CU separation BNG device, the information model is divided into two parts. One is the control plane information model used by the control plane devices, and another is the user plane information model used by the user plane devices. The control plane information model focuses on the information model related with such as the user's information, the service interface information, and the device.
To finish.
Okay, the next slide, this is. And the user plane information model, it contains some available network resources such as the port resources information and the traffic statistics. If you want to go to the details, you can refer to our draft. Yeah, next slide is maybe the thanks. And we think this model enjoys the journey in IETF because we first meet the interface to routing system, and then we meet the routing work group. We meet new friends. So here I wish everyone can enjoy the journey like the same as our work group, as our draft.
Thank you for the presentation. We are excited to have you here and be good friends. And looking forward to hackathon and results. It's great. There's code besides.
Okay, I will.
The model. Great to see everybody. Thank you for your attendance, and we'll see you in London.